Hello folks, and welcome to week 3 of Introduction to Data Science. You can see on the website now that there is a week 3 page, which maybe that's how you found this particular video as well. So let's click on the week 2 before we get into week 3. I just want to kind of recap what we were doing last week. So now we're on the week 2 page. You can see that your tasks were firstly to do the first time setup instructions. If you haven't already, I think most of you have by now. Watch the videos, do the readings, complete the assignments. These are your normal tasks that you will normally have each week. And so you can see that the videos that we were watching were mostly about ggplot and how you can visualize different types of data, numerical data, categorical data, and an application exercise to help consolidate those ideas and to have some practice. I really recommend, if you didn't get round to doing the application exercise, that you give it a go just to solidify some of those ideas of how to do different types of plots. Now we had different assignments. Now we had our first actual marked one, which was the first quiz. Remember, all the ones with 0, were not marked. They were just for practice. And so for our first quiz that was handed in last night, because I record these on Mondays, we're going to go over some of the common questions that you had as a group on some of the questions that you found particularly hard on the quiz, and we'll do that after this. Now, next week, which is now this week, we have the Lab 1, which is due on Tuesday, so tomorrow from when I post this, and then our weekly quiz, as always, on the Sunday. The readings for this week were a chapter from the R for Data Science book and a data visualization textbook. And we had some optional ones, including a paper that was made about ggplot from the original designer of ggplot, which you might find interesting if you want to learn more about how it was designed and why it was designed in the way it was. We've posted our code along session, which was on Thursday, and we added these 2 interactive R tutorials, which are optional, but we highly recommend that you at least try the Airbnb one because it introduces the data set that you're going to be using in homework 1, which is going to be the homework that's released from this week. Now, I'll have more information on this week later on in the video, but for now, let's go back to our quiz and have a look at some of the common questions from the quiz. A common question that students wanted us to go over based on the feedback that you provided us when you submitted the quiz was question 3. Now, question 3, we want to know why this plot is not super useful, but first we need to make this plot. So you start with this, and we need to use this MPG dataset, of which we had some prior information on in the previous tab. And we need to fill in the blanks to make a scatter plot of class versus DRV. Now, what's DRV? It's the type of drive. You could find that on this line here. So F is front wheel, R is rear wheel, and 4 is fore wheel. So let's take our data set that we know is called MPG and put that in as the data in the ggplot command. Put this in as class, and put our DRV on Y, and run our code. And now we can see that we've got a scatter plot that is plotting 2 categorical variables against each other. And so these points are not super useful. They're not really helping us know too much information. We reckon that there's probably a better way of plotting this information that's more useful. Now, if you're not really sure exactly what sort of plot to use, then I do recommend you go back through the videos, have a look at some of the graphs that we recommend for numerical data or categorical data. You could, of course, try some of these different plots here. You could try Geom box plot, for example. Maybe you think this would be a good plot to use. And you can see all it's done is it's replaced the dots with a line, and that's not super useful. So that's a suggestion that this actually isn't a very good plot for this type of data. And you could try that with all the different ones if you wanted to, but I do recommend you having a think about, well, what is the appropriate type of plot based on the type of data we have? And in this case, we recommend the segmented bar plot. Now, you may be wondering, well, what is a segmented bar plot? And if you go to lecture 5 of last week, Mina discussed what a segmented bar plot is. And if you go through the slides, you can get to this particular slide here, where you see that here we've got a fill as a grade in this particular data set here, and the position is fill. And essentially, this is showing the percentage of ownership based on the grade of, I presume, a loan or something. So let's kind of use this idea of this particular data set here and apply it to the data set that we were using in the quiz. So now here I've come back to the quiz and I've changed my mapping aesthetics so that we have fill by DRV and we have a position equals fill. So now we are filling our bars according to the type of drive that the car is. And so now we get the proportion of two-seaters that are rear-wheel drive in our data set. And we can see that all of them, it looks to be our rear-wheel drive. Then our compact, we can see that most of them are front wheel, with some of them four wheel, and so on. So this is quite giving us some useful information, much more useful than the scatter plot was giving us. And the scatter plot was a lot harder to interpret. So that's why we recommend this particular graph for when you're trying to plot two different types of categorical variables, our class and our DRV. And if you wanted to improve this plot, you'd probably want to give it a title. You might want to tidy up these labels using the information from the data dictionary before. And, you know, that goes beyond what this quiz question was asking, but hopefully it makes sense why we recommend a segmented bar plot in this case. Another common question that people wanted us to go over was question 5, and this is around the style guides. Let's move this in the middle here. So which of the following is not a change that needs to be made to align the code above with the tidyverse style guidelines? Well, I guess the first question is, where can you find the tidyverse style guidelines? Well, we can use Google. So let's type in tidyverse style guide, and we can click on this first one. And we can see that this is the tidyverse style guide. It's based on Google's original style guide, and we're going to be using this on this course. And you can see various in the tables of contents, various information on different parts of R and suggestions on how to style that according to the guide. And you could go into here on the website, have a look at some of the information, and that could have helped you answer this question. Let's go back to the question and have a look at how it was worded, because it can be a little bit tricky to know what the question was asking. So let's have a look at doing some of the things that it suggests. So let's start with needs a line break after the pluses. So that sounds reasonable. Let's put a line break after our pluses. It's starting to look a bit nicer. This is the correct answer, so we'll just skip this for now. Needs spaces around the pluses, so let's put some spaces. It seems there's already a space over there. Need to move the filter statement out of ggplot. That sounds like it'll be useful, because at the moment this data thing here, it's looking pretty complicated. So let's put this here. So we're starting with the data. We then filter the data. And then we're going to pipe it into our ggplot here. I'll remove this. And so now, because we're using the pipe, we start with our data, we filter it, and then it goes straight into our ggplot. So we don't need our data anymore. We're going to keep our mapping argument. We're going to keep that. It's nice and easy. But to be honest, like, it's so common that we could just remove it, maybe tidy it up a little bit more. So we have our aesthetics. Now you can see that we've got some spaces around our equal signs, which just kind of spaces it out a little bit, makes it look a bit nice. And so this is a lot clearer of what we're kind of looking for. It just makes it look a lot nicer. And there we go, it runs nicely. You can see I've made some indents as well to make this extra clear what's going on. You don't have to do all the indents. In fact, R ignores some of the spaces when it runs some code, but that's just something that I decided to add to make it seem a little bit clearer. Now, why specifically needs the line breaks after the pipe operator? Now, in the answer it says, although we should use line breaks, which is what we're doing here, the biggest problem with that particular part of the code was not necessarily the line breaks, but more the fact that we did need to move that filter statement out of the ggplot. So really the answer here was saying, if we go back to our original one that looked like this, if we made our spaces around here and even made a line break here, that still looks very complicated. In fact, it hasn't actually really helped things at all. It actually makes the statement look even more confusing. So that's why the answer was the way it was. I understand this is a little bit worded in a tricky way, but hopefully you understand that if you just put the line break here, that it wasn't necessarily adhering to the style guide any better than it was before. In fact, moving the data out would have been the best outcome. Another question, the final one that I'm going to go over, is under the title of what's happening here. And so it says to have a look at the data frame below. And let's just run the plot to start with. We can see that the plot has 3 data points here. But it does say to take the look at the data. So let's have a look at the data and see why this is a strange plot. Let's run the code. Well, the data has 4 data points and not 3. So if we go back to our plot, we can see that actually we can only see 3 data points, but we should be expected to see 4. So clearly there's nothing wrong with this plot is not the correct answer because we should be seeing 4 data points. You could try using geom density and geom histogram, but hopefully when you did geom jitter, if we try that, just misspelled it. That you can see here that now we've got our 4 data points. And you can see now that it seems to be that there's some sort of like pattern here in the data that we couldn't necessarily see before. But I wouldn't worry about that too much because what geom jitter is doing is it adds a little bit of random noise to every bit of data. And so by separating the 2 data points that were originally overlapping, because remember we had 2 versions of this 1-1 which were hidden because they were overlapping each other. So we were just using geom jitter here to add a bit of random noise. You see it's a little bit different this time onto the graph. So now we can actually see the 4 data points. They're not overlapping anymore. Now you may want to go inside geom jitter and change some of the parameters. So maybe you add a little bit less noise. And I think another question that we'll just quickly go over is, well, how do I know what parameters different like geoms have available to them? So here we can go back to Google. So let's try ggplot and I'll just click on the first one. And this is one of the ggplot pages, but it's not the main page. So let's start from there. And this is the main page. We can see a little overview of what ggplot is, how to install it. It's very common for R packages that it will start with how you install the package. You've got a cheat sheet here. And the cheat sheet is quite useful for quickly finding what different functions do. It's normally a bit easier once you know what they do, but later in the course you might find that this cheat sheet is really useful to use. We link to it on the idsed.digital website under resources, and some other information about how you use ggplot. But the thing that we want to know here is reference. And this now has information about all the different things in ggplot. Now we were looking for information on geom jitter. So I just used Control F and typed in geom jitter, and you can find it here. And now we can see all this information about all the different things that are useful and are parameters for geom jitter. And you can see these arguments here and some more information on them. Now of note here is the width parameter. And that is the amount of vertical and horizontal jitter. So I said before, maybe we want to have a look at increasing or decreasing the amount of noise. Well, we can adjust this width parameter. In fact, on this page, it gives us lots of examples, as you can see here. And one of the examples further down is what happens when you change this width argument. You can see here, this is what this data looks like before changing the width from its default value. And then this is what happens when the width is 0.25. So you can see it gets less spread out. It bunches together, which in some cases you might feel is a more accurate representation of the data that you're trying to demonstrate. Remember, if we didn't have any geom jitter, I don't think there's an example here, but on this data set, it would all just be on one line. So we're trying to bunch them out so we can actually get more information on this data. It's a lot more clear. Here we go. This is what it would originally look like. If you have a question about the quiz that wasn't answered in this part of the video, then please post them on Piazza now and we'll discuss them on there. Now that the quiz is over and it's submitted for last week, the assessment is closed, you're more than free to discuss these with your teammates and to think about why the answers were what they were. So please post them on there and we can carry on the discussion about different questions on Piazza. I'm now going to throw over to Alex, who's going to talk about some of the questions that you might have had resulting from the labs on Friday.
Okay, so I have two things to add to David's comments this week. The first one is about personal access tokens, or PATs or PATs, and we provided some instructions on how to create one of these and use it instead of a password on your RStudio Cloud session. Use it where it says to put in a password. You don't type in the password itself, you type in the PAT. And we told you that you would need to create one every time you create a new project, but then it would remember it for that project. Now, we're getting reports from students that that's not true always, that sometimes RStudio is not remembering it between sessions. And I don't know exactly why that is. But you're not the only one if you're experiencing that, and I'm sorry if you're experiencing that. There are two solutions to this. One is just to create a new one every time. That's a little bit time consuming and it's frustrating, so I can see why you might not want to do that. The other thing is to do what I actually do, which is to store, to create one PAT for a period of time, let's say 30 days is the default, and to store that in a password manager. So there are a lot of password managers available. I wouldn't recommend any particular one. There's Keychain on Macs, which sort of works in the system, and in Safari. There's Lockwise with Firefox. There's one that comes with Chrome. There are commercial ones available as well. And you could store it in there as if it were a password. I would strongly not recommend storing it in plain text. So, putting it in a Word document or a Notepad file or something along those lines. I really wouldn't recommend that because a PAT is like a password. And so if you store it in plain text, you're leaving it vulnerable to being accessed by somebody if they manage to get into your computer. So please put it in some sort of password manager. Don't just store it in plain text, but if you want to keep the same PAT and store it there, that's fine too. The other comment is more about R coding itself, and it's about how we might scale graphs. It came up in the last question of the lab, and I'm not sure we'd explicitly told you how to do this yet, so I'm going to tell you now. So let's take some sample data. I've used the function tribble, which lets you create a sort of simple data or tibble using relatively sort of plain text methods, sort of typing it row by row as if it were a table. So I've done that here. So you might notice that y is approximately equal to x, with the exception that for x equals 4, we have y equals 45. Now that might be a data entry error, but let's say it's not. Let's say, or at least we don't have any strong evidence that that's just a data entry error. That might just be the real value when x equals 4, and barring anything else, we have to keep that point in. We can't just throw points away unless we know that they are data entry errors. So here's what you get if you plot that as a scatter plot and put a line of best fit on. So that plot is fine, except it's a little bit hard to see what's going on with the lower values, to see exactly whether they're going up and down or anything like that. And you saw this problem with the plastic waste data, a very similar thing. It was really hard to see the pattern, but even more extreme. So it might be that we want to crop out that outlier. Now, if we're going to do that, we have to disclose that we've done that. You can't just hide outliers. That is a breach of data ethics. So you need to say that you've done that. And so I'm going to do that by putting a little note in the caption. But there's a few ways to do this. So one way you could remove it is to say, well, okay, let's just keep the points that are less than 20. It's obviously above any of the other points. And we can do that. The problem is then that the line of best fit we've got has moved itself. It's moved itself to be nicely between these lines. And that's all well and good, but that's now not taking into account the fact that it's assuming that the point at x equals 4 has just disappeared and just isn't there. And we can't do that. We don't have statistical justification for that, because that point may well be valid, and so we may need to take that into account when we're drawing our line of best fit. And also it's made the error sort of shaded area, the confidence interval as it's called, it's made that a lot narrower, because now all the points are quite close to a line, whereas when that point was there before, if we look before, that's quite a wide bar, which accounts for the considerable uncertainty introduced by this one rogue point. So here we have this much narrower error bar, and there's no justification for that. That's a similar sort of breach of data ethics as it would be not disclosing the point. So yeah, we've disclosed that it's not there, but now we've got an invalid error bar. Okay, so what other approaches could we take? Well, we could manually scale the y-axis to just crop that point out. So first thing to say, we can see the regression line and the true regression line and all of the other values there between 0 and 20, and that's including actually a bit of the edge of the confidence interval as well. So we might choose to show the points between 0 and 20 on the y-axis. So one function for that is scale y continuous, and if we try that, we get some warning messages for both the stat smooth, which is what's happening in the John smooth function, and the John point. So what's happened there is actually when we've scaled the y-axis, it's effectively just filtered out those points again. It's gone back and actually removed them from the data, or at least replaced them with NAs, probably is what's happening under the hood. And so when we try and plot it, it's warning us, okay, I removed some points now. And when we look at that, we get, okay, the axis is now between 0 and 20, but those points in that line are exactly what we had a couple of slides ago. That's as if we've just filtered out those points. We've got this line with this really, really narrow error bars around it. So it turns out the function that you need to use if you're going to scale a graph like this, if you're going to try and crop out points, is one called coord Cartesian. So if we run that, and the syntax for that is on the screen, you can see that we sort of zoom in on the graph. You get the edge of the shaded error region, confidence region there. And you get the line above all of the points, which is exactly where it should be when we have this one point that we can't remove. And again, we've still disclosed, I put it in the caption of the plot there using the labs function, I've disclosed that I've removed this point at 445. So if you want to scale a plot, the function uses coord underscore Cartesian, and the options using that are xlim and ylim. So xlim equals c brackets the two limits, and ylim equals c brackets the two limits. The c here represents that we're giving it a vector of two numbers. So the ylim, the limits on the y-axis, are two numbers, 0 for the bottom and 20 for the top. And you just use c to tell R, okay, this is a vector of two things. You'll see that function a little bit more. It's an inadvertent pun there. You'll see that function quite a bit more as we go along. So there you go. Coord Cartesian is the way to scale a graph.
Thank you, Alex. So now let's have a look at what we have to do in week 3. So if we go on the web page, we can see that our tasks are pretty straightforward as usual. Do the videos, do the readings, do the assignments. We have all our videos up. Obviously, this is the Keeping Up with IDS week 3. And you can watch the videos, and there's a link to the application exercises repositories, which you can use as you always do by cloning it into RStudio Cloud and working on a version there. We have the assignments. You can see that this week, due on Tuesday, which is tomorrow, is the Lab 01. Please make sure that you have made a commit and pushed your changes as part of your group work to that repository before this deadline. After the deadline, you won't be able to push any more work. You'll just get an error. So if you see an error when you're trying to push and it's after 4 o'clock, then that's a deliberate error. It's to stop you being able to submit your work after the deadline. The data wrangling quiz is going to be Sunday, and you can see next week lab on Friday, and that needs to be submitted by Tuesday. I'll make repositories for those later. The homework 1, that is going to be, that's created now. If you click on the repository link, you should be able to see your repository for that. And you can also find the instructions for Lab 1 as well by following the link there. So that is due on Thursday the 14th, again at 4 o'clock. Remember, these are to be completed by yourself. If you have any questions, feel free to post on Piazza, but make sure you only tag the instructors, and we're more than happy to help you out with this homework. But try not share your answers with the whole class, because we want to make sure that this is an accurate representation of what you've been learning over this course, so it reflects your abilities, just like an exam does. We don't have exams on this course. That's why we have a lot of different types of assessments, the homework being one that we assess you as an individual. We have a number of readings. This week, they're all from the R for Data Science book. We've tagged 2 as required and the rest are optional. And again, like usual, we'll post the code along on Thursday after we've recorded it. And again, like last week's, I really recommend that you have a go at the interactive R tutorials, in particular the road traffic accidents one, because it's using the data set that we're going to be using in the homework. There's two data sets in the homework. One of them is the Airbnb data, which was in last week's interactive R tutorials, and this week the road traffic accidents is also used in the homework as well. So I do recommend that you do those. I hope you have a good week. I'll see you at student hours tomorrow online. So that's on a Tuesdays, or on Wednesday in person. And then we have the code alongs on Thursday, and the workshops as always on Friday. Message me if you're having any problems accessing repositories or your teams. Otherwise, post on Piazza, and we'll talk to you on there. Okay, see you later.